Okay, we'll study a magnetic coupling circuits. This is very interesting and one of the important topic. Magnetic coupling circuits, there are two types actually. Basically, magnetic circuit, how that is coupled with the other one. This is called as magnetic coupling circuit. First level is magnetic circuit, followed by magnetic coupling circuit. But but we are studying reverse. Magnetic coupling circuit first, then magnetic circuit. Any order we can study, not a big issue. And this topic is based on inductor principle. For understanding inductor, earlier in the beginning, I told four important points. One is Faraday first law, Faraday's second law, then right hand thumb rule, Lenz's law. What is Faraday's first law? Whenever conductor cuts the stationary magnetic flux or varying flux cuts the stationary conductor, and EMF is induced in the conductor. The second one is quantity of EMF depends on rate of change of flux linkage, that is E equal to N d phi by dt. Third one, right hand rule. When these four fingers indicate current direction in the coil, then thumb indicates the direction of the flux. This is Lenz's law. Sorry, this is right hand thumb rule. Fourth one is Lenz's law. Lenz's law is whatever EMF is induced, oppose the cause which is producing. Whatever EMF is induced, oppose the cause which is produced. These four things I explained earlier when I introduced the inductor in DC analysis beginning topics. So those laws are again applicable in this, because again we are using inductors only, they are coupled. So Faraday law says when voltage is coming. Second law says how much voltage is coming. And Lenz's law tells us what is the polarity of induced EMF. Which side positive, which side negative is decided by Lenz's law. And right hand rule is helpful to determine the direction of the flux when we know the direction of current in the coil. So these four again we are using in this topic. Magnetic coupling circuits are important for one reason. Any topic till now, whatever we studied, the topic can be linked with the magnetic coupling circuits. Theorem can be linked to this topic. Transient analysis can be linked to this topic. Two-port networks can be linked. Steady state analysis can be linked. Resonance can be linked. Construction of power triangle can be linked to this topic. So all the topics, whatever we studied till now, they can be linked to magnetic coupling circuits. Most of the university syllabuses, they teach this in the first unit only, and all other topics, and this will go as a part of the topic. But I am going little reverse, and once I explain basic principles, we will solve variety of problems, how it can be linked to theorems, how it can link to transient analysis, and so on. In that sense, this topic is more important. Examination point of view, any competitive examination point of view, theorems is studied but coupling not studied. If they form a question between coupling and theorem, then you can't answer. So at any cost, don't leave this topic as a choice. All of you compulsorily prepare this. This topic is not complicated one, a little bit of confusion. The confusion can be eliminated if you listen all the classes carefully. So in this mainly dot concept we focus, meaning of dot, sign convention of the dot. So the whole topic will go around the dot. Dot meaning, dot convention. So now let me explain. This is the basic theory and there is a derivation. So fundamentals we study now. So this one is a primary coil N1, secondary coil N2. So this one is a primary coil. This one is secondary coil. Number of turns in secondary N2, number of turns in primary is N1. Now we are applying V1. V1 is a sine wave. In coupling circuits, compulsorily we apply AC only. If DC is applied, then energy will not be transferred to other circuit. So compulsorily AC voltage is applied, sine wave is applied. Then the current I1 is also positive, negative, positive, negative. So current is also sinusoidal, voltage also sinusoidal. Now during positive half cycle of the current, this is the current to direction. When this is the current to direction, if we use right hand thumb rule, 4 fingers indicate the current to direction, then thumb indicates the upper side. So this is the direction of flux. So flux will go like this and come back. So this is the direction of flux as long as current I1 is positive. If current is negative, then direction is changed now. When direction is changed, then flux direction also will change. Flux direction will go reverse. So during positive half cycle, flux will flow in clockwise. During negative half cycle, flux will flow anti-clockwise direction. So flux is also like a sinusoidal. Flux is also like a sinusoidal. So this is the current I1. This is voltage V1. This is flux. So total flux is phi1. Positive flux means clockwise direction. Negative flux means anti-clockwise direction. So continuously V1 is changing sinusoidally. I1 also changes sinusoidally. Phi1 also changes sinusoidally. The total flux induced in the primary is indicated with phi1. Out of this phi1, some flux cutting N2 coil, some flux not cutting the N2 coil. What is cutting is phi12. What is not cutting is phi11. Phi11 plus phi12 is equal to phi1. Now, using Faraday's first law, whenever varying flux is cutting stationary conductors, voltage should come. So first law, as per the first law, voltage will come. How much voltage will come? That value depends on what? N1 d phi1 by d. N1, the total flux is phi1. So d phi1 by dt, this product will give induced EMF in the primary. This is called as a self-induced EMF. That is called as self-induced EMF. Then part of the phi 1 is phi 12. Phi 12 cutting secondary coil. Then again we get the voltage across the secondary. What is that value? N2 d phi 12 by dt. That is named as mutually induced EMF. Mutually induced EMF. Then the value of mutual induced EMF depends on N2 d phi 12 by dt. The phi 12 value depends on the coupling coefficient. What is the coupling coefficient definition? K is phi 12 by phi 1 or phi 21 by phi 2. Phi 1 is total flux developed. Out of this, a part of it is cutting secondary. So phi 12 by phi 1 or phi 21 by phi 2 is called as a coupling coefficient. If secondary coil is far away, then phi 12 is 0, K will be 0. If secondary coil is closer and closer, then phi 12 is becoming almost phi 1, then coupling coefficient K value will become 1. So 0 is the worst coupling, 1 is the best coupling. Coupling coefficient value changes from 0 to 1. So secondary induced EMF value depends on phi 12 value and the number of turns N2. Phi 12 depends on the coupling coefficient K. Now, the same way, if we apply this side V2, V2 is also again AC waveform, then I2 also sinusoidal current waveform. Then the flux what is generated is here phi 2. Total flux induced is phi 2. It will go, if you see I2 is positive, this is the current direction. This is the current direction. Then thumb will be downward. Then flux will go clockwise. Flux will go clockwise as long as I2 is positive. When I2 is negative, again flux direction will be reverse. So what is the total flux induced here is phi 2. What is the self-induced EMF? N2 d phi 2 by dt. How much is cutting primary? Phi 2 1. Phi 2 1. Then we get a mutual induced EMF. What is that value? N1 d phi 2 1 by dt. If I apply V1, V2 both simultaneously, we get self-induced EMF, then mutual induced EMF both will come. If you see the equation here, V1 is equal to N1 d phi 1 by dt is the self-induced EMF. Self-induced EMF. And other one is mutually induced EMF. Okay, so one is self, second one is mutual. Mutual because of V2. Then this side V2 expression N2 d phi 2 by dt is self, N2 d phi 12 by dt is mutual. And this self and mutual added. Why it is added? Why this is plus? The reason is when I1 is positive, flux is flowing in clockwise direction. When I2 is positive, again flux is going in clockwise direction. When V1, V2 both are applied simultaneously, self flux, mutual flux both flow in same direction. So total flux is nothing but addition of self and mutual. Therefore, self-induced EMF and mutual induced EMFs are added. The same reason for V2. So plus is based on direction of the self and mutual fluxes. Minus, when minus will come, self flux direction is clockwise, mutual flux direction is anti-clockwise direction. If both the fluxes are flowing in opposite direction, then total flux is the difference. Therefore, EMFs also differences. That is the basic concept when it is plus, when it is minus. So V1 is self plus mutual, V2 is also self plus mutual. Next. Now here, what is visible? Winding direction is visible. N1 and N2 winding directions are visible. Therefore, we can determine the flux directions using right hand thumb rule. Now, if winding directions don't know, flux direction we can't determine. Now, this whole concept is replaced with another single equivalent circuit. But in this equivalent circuit, N1 replaced with L1, N2 replaced with L2, V1 I1, V2 I2 as it is, K replaced with M. What is L1? Self-inductance. L2 self-inductance. What is M? Mutual inductance. What is the formula for L? Mu A N square by L. Na? If N is becoming N1, this is L1. That's why N1, this whole coil, replaced with a symbolic representation of the inductor, that is written as L1. Similarly, secondary L2, and based on the coupling, mutual inductance, the M is coming. That is the reason. Then why this dots are placed? What is this purpose of dot? Mainly, this dot is important. The reason for keeping this dot is direction of the windings not visible. So to draw this circuit, we have to show the core, and it takes more time to indicate the winding direction. But each time it takes a lot of time. This is a symbolic representation. In this symbolic representation, we are not bothering what is the winding direction, but that is taken care by location of the dot. So dot indicates the winding direction. Dot indicates the winding direction. That will not indicate the current direction. So always dot indicates winding direction. Winding direction. Not current direction. Not current direction. Okay. So when dots are there, then what is the dot sign convention? The dot sign convention will go like this. When current I1 entering at dot induce open circuit voltage in the secondary with a positive reference at dot. I repeat, the current I1 in primary entering at dot induces open circuit voltage in the secondary with a positive reference at dot. Alternative way of telling, the current I1 entering at dot, sensing at dot is positive. Sensing at dot means measuring at dot. Measuring at dot means the way how you are connecting the voltmeter. Any voltmeter will have a red button and a black button. If red is connected to dot, black is connected to undotted. When current I1 is entering at dot, definitely that voltmeter will read positive quantity. The same way, when I2 is entering at dot, sensing at dot is also positive. What are the other combinations? Entering current I1 entering at dot, but sensing at undotted. Sensing at undotted is negative. Then another combination. I1 entering at undotted, but sensing at dotted is also negative. Fourth combination. I1 entering at undotted, sensing at undotted is again negative. Negative will be positive. So what are the four combinations? I1 entering at dot, sensing at dot is positive. Any one condition changes negative. Both the conditions changes again positive. This is called as a dot side convention. Okay. Now this dot sign convention easily how to remember. Entering at dot, sensing at dot is positive. Any one changes negative. Both the condition changes positive. This is the short form of or easy form to remember. But in the interview, don't tell this short form. You have to tell elaborated statement. The current I1 entering in the primary at dot induces open circuit voltage in secondary with a positive reference at dot. Means sensing at dot. Means measuring at dot. Means voltmeter red button connected to dot. Then that is positive. That is an elaborate statement. So now I explain the dot sign convention. So using dot sign convention, then how to write expression for V1. So here I1 is entering at dot, sensing at dot. Na? So what is the value I get here? M di1 by d. Then I2 is entering at dot, again sensing at dot. What I get here? M di2 by d. Now we have to write the expression for V1. What is expression for V1? L1 di1 by dt. L1 di1 by dt. Why this is plus? Plus L1 di1 by dt. Why this is plus? The reason for plus is, as I told earlier, start from positive, go to negative. The direction, I1 direction both are same. Same means plus. So plus L1 di1 by dt. Self-induced EMF plus minus is based on KVL sign convention. Don't apply dot sign convention here. Then mutual induced EMF polarity based on dot sign convention. So here I2 is entering a dot, sensing a dot, therefore this is positive. But when I am writing expression for V1 going from positive to negative, na, again plus. So plus M di2 by dt. The same way V2 expression L2 di2 by dt is self-induced EMF plus M di1 by dt is mutual induced EMF. Remember, these two circuits are equivalent. First case, winding directions are visible. We never keep dot notation. Second circuit, winding directions don't know. That is taken care with the help of dot. When dots are there, we talk in terms of L1, L2, M. When dots are not there, we talk in terms of N1, N2, K. And this is self-mutual. This is also self-mutual. Here also self-mutual, self-mutual. Now self-equated. So these two are equated. N1 d phi1 by dt is equal to L1 di1 by dt. dt cancel. So expression for L1 is N1 d phi1 by di1. Same way L2 is N2 d phi2 by di2. Then mutual also equated. M12 equal to M21 is equal to M. Symmetrical coupling is equal to N1 d phi21 by di2 is equal to N2 d phi12 by di1. So it is easily just to self and mutual compare, you get these equations. Next to m square, m into m square. So just to multiply these two products, m square. So now what is 5 to 1? 5 to 1 is k times of 5 to na. So here k times of 5 to, k is a constant taken out, d phi 2 by di 2, n2 as it is. Then phi 1 2 is k times of phi 1. So k d phi 1 by di 1. Now k into k square. Rearrange the terms. N1 d phi 1 by di 1 is one combination. N2 d phi 2 by di 2 another combinations. Therefore, m square equal to k square into L1 L2. Above, if you see, they are equal to L1 L2. From this, k equal to m by root L1 L2. This is one important derivation. Then what is the range of this k? K ranges from 0 to 1. Therefore, m always less than or equal to root of L1 L2. This is asked in one of the gate exams. So this is important. This derivation is important. Later we solve problems based on these formulas. So there are few rules. Flux rule. What is flux rule? In first set of equations, plus or minus is based on flux rule. And the second equations, plus or minus based on the dot convention, dot sign convention. So what is the flux rule? When both the fluxes are in same direction, self and mutual induced EMF will be added. If they are in opposite direction, it will be subtracted. So same or opposite depends on the winding directions shown. For the winding directions shown, we have to keep both the dots upper side. If secondary coil direction is changed, secondary coil dot will come down. If first coil winding direction is changed, then primary dot will come down. If both are changing, again both will come down. Both the directions are changing, again it is equivalent to same only, because entering at undotted, sensing at undotted is again positive. So that is what dot sign convention. So dot sign convention is in a short, current I1 entering at dot produce open circuit voltage in secondary with positive reference at dot. If you remember this, then all four combinations we can tell easily. So flux rule is discussed. Meaning of dot understood. Dot indicates what? Dot indicates winding direction. It will not indicate current direction. And also discussed the dot sign convention. Next, dot rule will come. Next slide is dot rule. So what is the, once again I am summarizing key points. What is K? Coupling coefficient. So phi 1 2 by phi 1 or phi 2 1 by phi 2. What is the range of coupling coefficient? 0 to 1. 1 is the best coupling, 0 is the worst coupling. Dot indicates the winding direction, it never indicates the current direction. So dot will take care of winding direction. For the coil directions shown in first figure, both dots will come upper side. That is the reference to keep it in mind. Then flux rule is what? Both the fluxes are same direction, self and EM mutual will be added. Then what is dot sign convention? Current entering at dot, sensing at undotted is, entering at dot, sensing at dotted is positive. Any one condition failed negative, both the conditions fail again positive. So this is the summary and these two conclusions. Next, we will discuss a dot rule. So this is the four cases: case 1, case 2, case 3, case 4. And in case 1, here there is a dot. Here there is a dot. Here there is a dot. So what is the L equivalent? Second case, here dot, but here dot is shifted other side. Third case, first coil dot is shifted, and second coil it remains same. Fourth case, both the sides dots are moving other side. So in these four cases, what is L equivalent? So first case I have given the derivation. Second, third, fourth answers directly given. So to find L equivalent, always we assume some current is entering. So I we are sending, so that is entering at to dot. Then sensing at to dot. Here I is entering at to dot, sensing at to dot. So entering at to dot, sensing at dot is plus. And what is the mutual inductance between these two? M. So M di by dt. Then same current I is entering here. So entering at to dot, again sensing at to dot is again plus. So what is its value? M di by dt. So therefore here M di by dt, here also M di by dt. Now write the expression for V1. You will get L1 di1 di by dt plus L2 di by dt plus M di by dt plus M di by dt. Remember, self-induced EMF polarity based on KVL convention and mutual induced EMF based on again KVL only. Here going from positive to negative is plus. Here also positive to negative we are going plus. But this MDI by dt is plus or minus based on the dot sign convention. So accordingly, we have written V1 equation. Di by dt is common, take it out. L1 plus L2 plus 2M will come. So finally, what is L equivalent? V1 equal to L equivalent into di by dt. So L1 plus L2 plus 2M is the L equivalent. Because of this plus, we call it as series aiding, added to, added. So that is the meaning. Aiding, adding L1 plus L2 plus 2M. So if this dot is coming to other side, then you get to minus 2M. Third case also minus 2M. If it is a minus, series opposite. If both the dots location changed, again we get a plus 2M. If it is plus 2M, call it as series aiding. If it is a minus 2M, call it as series opposite. But how to remember these four cases, plus 2M or minus 2M, based on the dot rule. Based on the dot rule. So dot rule will help us to write whether it is plus 2M or minus 2M easily. So how the current I entering at dot, here also entering at dot is plus. Second case, entering at dot, second case, entering at dot, entering at undotted, so minus. Third case, entering at undotted but entering at dotted, again minus. Here entering at undotted, again entering at undotted, therefore plus. So this is called as a dot rule. So if current enter in both the inductors at dot, plus 2M will come. If entering at one of the dot only, minus 2M will come. If it is minus 2M, series opposite, plus 2M, series aiding. So these four combinations very, very important to solve the problem. So if you look at this problem is based on these four cases, how it is done. So single horizontal core and winding directions. First one clockwise, second one anti-clockwise, third coil again clockwise. And here L1, L2, L3 given, coupling M12, M23, M13 given. The question is to find LEAB, L equivalent. It is L equivalent across A and B. LEAB is asking. So to find LEAB, what is the basic rule? Start sending current I. So how this current is flowing? Like this now. So this is the current direction. If this is the current direction, then using right hand thumb rule, flux direction is this. So this is the direction of flux. The same way, same current going, then here like this. If this is the current direction, flux direction will be reverse. Then again, this is the current direction, flux will flow this side. Now this flux is opposite. This flux is opposite. And this flux is in same direction. So what is the flux rule? I said same means plus, opposite means minus. So same way, LEAB equal to L1 plus L2 plus L3, and first coil, second coil fluxes are in opposite. Therefore minus 2M12. Second, third also opposite, minus 2M23. First and third same direction, plus 2M13. So like that easily we can get the L equivalent. Sometimes in the exam, they ask this way or this way. If it is in these two are equivalents, how they are equivalents? When I am taking L1, if I place first end dot, second coil winding direction is changed. So dot is shifted to other side. Dot is shifted to other side. Third coil direction is same as first coil. Therefore, third coil dot is at first end. Now using dot rule, entering at dot, entering at undotted. So minus 2M12. Then second and third, entering at undotted, again here entering at dot. So minus 2M23. First and third, entering at dot to entering at dot plus 2M13. What is the difference between these two cases? Here winding direction is visible. Using flux rule, we determined plus or minus. Second case, winding directions don't know, but that is taken care by dot. That is taken care by dot. If dot is there, we have to use a dot rule. If dot is not there, we have to use flux rule. Without dot, use flux rule. When dot is there, use only dot rule. Dot indicates what? Winding direction. So in the exam, any one of the format they ask. Please remember, if dot is there, use only dot rule. If dot is not there, by sending some current, determine the flux direction. Using flux rule, decide this mutual will be negative or positive. But remember, this self is always positive. Self is always positive. Mutual plus or minus based on the winding direction. And other problem can be, here directly there is a problem. Coupling is given, dot notation given. So here self J1, J2, J3, J4. XAB, reactance across AB. So what is XAB? J1, J2, then J3, J4. All these are all self. Now these two coupled with J1, these two coupled with J2, these two coupled with J3. So this coupling, how? Entering at dot, entering at undotted. So minus 2 into J1. Next, here entering at undotted, again entering at dotted minus. So minus 2 into J2. Then these two here, current entering at undotted, because I am looking at this now undotted. Then here entering at undotted. Here also entering at dotted, here also entering at undotted. These two coils point of view undotted. So undotted means plus. So plus 2 into J3. And simplify, you will get answer. So this is directly, if reactances are given, they ask XAB. If L1, L2, L3 given, they ask LAB. So any one of the way they can ask the question. So this is more typical problem, coupling between three coils. Now how are they coupled? Then what is L16 if 2, 3, 4, 5 connected? What is L16 if 2, 4, 3, 5 connected? Okay, so let me draw this problem, then only you will understand. If readily available, then you cannot understand. So let me use different colors. This is one direction. This is one coil. I am calling 1, 2. Then second coil is this. The direction is changed. Three, 4. 1, 2, 3, 4. I am taking another coil, third one. Is 5, 6. So 1, 2, coil 1, 2, 3, 4, 5, 6. These three coils are coupled. These three coils are coupled. We know that these three are coupled, but what is the question? Find how they are coupled. And this is tough. Why this is tough is, if all three coils are on same direction, we can use word clockwise or anti-clockwise. If we use this is clockwise, definitely this is anti-clockwise 3, 4. But what about 5, 6? Is it clockwise or anti-clockwise? Difficult to decide. That's why this problem is special. Now to understand the coupling, we have to start sending current. So this is the current direction. So this is the current direction. 4 fingers keep in the direction of this current, and thumb will be left side. So this is the direction of flux. And this flux will divide here. Some flux will flow like this. And remaining flux will flow like this. Okay. So when we are sending current, red current, this is how flux is flowing. Now let me send current at 3. So this is going like this. Then flux will go this way. And remaining flux will flow like this. The flux direction. Okay. Now I am using gray color. Sending from 5. So flux will flow downward. Then this flux flow, here it divides. Some will flow left, some will flow right. These directions are very, very important. Okay. So 5s and 6. color is gray, and black not used. Red is used. 1 to 192 red. 3 4 green. Sorry, blue. 3 4 or blue. Blue. Here gray. So 1 2 indicated with red, 3 4 with blue, 5 6 with gray. Now what is the question is, how are they coupled? You have to answer A bit. 1 2 3 4 coupled, 3 4 5 6 coupled, 1 2 5 6 also coupled. To answer 1 2 3 4 how they are coupled, you observe the 1 2 3 4. 1 2 3 4 red and blue only na. So red blue direction. Red blue direction is same. Here red blue, sorry, red blue direction opposite. 1 2 3 4 na. We are discussing 1 2 3 4. 1 2 red, 3 4 blue. So red blue directions are opposite in coil 1 2. Coil 3 4 also red blue opposite direction. When they are in opposite direction, we have to indicate with when fluxes are opposite. If dot is coming here, then in this coil, other side dot will come. So these two coupled with dot. So location of the dot is determined with the help of flux rule. If both the fluxes are same direction, I will place at 1 and 3 or 2 and 4. Here fluxes are flowing in opposite direction, therefore I am placing at 1 and 4. Because I am sending current from 1, 3, 5. Not necessary. We can select 2, 4, 6 also. Not necessary. You can select 1, 3, 6. Any combination you can select. But in this problem, I selected 1, 3, 5. So 1, 2, 3, 4, these two coils, how they are coupling, we are answering by sending current at 1 and 3, and fluxes in these two coils flowing in opposite direction. Therefore, I am placing dot at 1 and 4. Similarly, 3, 4, 5, 6. If I see 3, 4, 5, 6, I should concentrate on blue and gray. So 3, 4, blue, gray, same direction. 5, 6 also blue, gray, same direction. That means if I place a dot at 3, I have to place a dot at 5. But if I place same dot, what is the confusion? These two coupled with the dot. If I place a dot here also, confusion. Therefore, now instead of dot, I am using triangle. So triangle is placed at 5 and 3. So 3, 4, 5, 6 coupled with the triangle. Why triangle is placed like this? Gray, blue, same direction in coil 5, 6 as well as 3, 4. And we should observe flux directions in 5, 6, 3, 4 only. Don't observe elsewhere. Because when we are deciding to know coupling between two coils, observe the flux directions in those two coils only. That is very, very important. Then last 1, 2, 5, 6. 1, 2, 5, 6 means red and gray. So 1, 2, red, gray, same direction. 5, 6 also red, gray, same direction. That means if I place a dot at 1, I have to place dot at 5. Just for a change, I can also select 2 and 6. Instead of using dot or a triangle, purposefully I am using some other notation, square. So square is placed at 2 and 6. So 1, 2, 5, 6 coupled with the square, 1, 2, 3, 4 coupled with the dot, 3, 4, 5, 6, 3, 4, 5, 6. Coupling indicated with the triangle. So dot to triangle square is used. Now I answered what? First bit. How they are coupled. Like this they are coupled. Coupling is indicated with the dot to triangle square. This is part A concept. What is part B? L16 equivalent inductance between 1 and 6 if 2, 3, 4, 5 connected. 2, 3 and 4, 5 connected. 2, 3 connected, 4, 5 connected. So what is L16? So L16 obviously this self-inductance L1, this is L2 and this is L3. So we get L1 plus L2 plus L3. This is always positive. Now the coupling between these two L1 and L2 is indicated with dot. That means M dot. And between 3, 4 and 5, 6 triangle, M triangle. Between 1, 2 and 5, 6 M square. Like that I am using. Now, now listen carefully. Sending current here. So this coupling between 1, 2 and 3, 4. So here current entering at dot. Here current entering at undotted. So therefore minus 2M dot will come. So 1, 2, 3, 4. Here current entering at dot and second coil entering at undotted. Therefore minus. Then 3, 4, 5, 6. 3, 4, 5, 6 means what I have to observe? Triangle. Apply dot rule on the triangle. So current entering at triangle, again entering at triangle, therefore plus. So plus 2M triangle. Okay. Next. 1, 1, 2 and 5, 6. 1, 2 and 5, 6. So 1, 2 is what? Current entering at unsquare because 1, 2, 5, 6 coupled with square. Na? So current entering at unsquare, again entering at unsquare. Here also unsquare, here also unsquare. Therefore plus 2M square will come. 2M square will come. So that is the point. So L16, 2, 3, 4, 5 connected, answered. Next case, 2, 4, 3, 5 connected. 2, 4, 3, 5 connected. Two, 4, 3, 5 connected. So under this condition, what is L16? It is as usual L1 plus L2 plus L3. Now current entering at dot here, again entering at dot. So therefore plus 2M dot. 1, 2, 3, 4 over. 3, 4, 5, 6. Current entering at untriangle, entering at triangle, untriangle, triangle. So minus 2m triangle. Then 1, 2, 5, 6. Entering at unsquare, again entering at unsquare. Therefore, this is plus 2m square. So like this, depending on this connection, this answer will change. When we are answering B and C, don't see the flux directions now. Observe or apply only dot rule on dot, triangle and square. Don't see the flux directions. We are using flux directions to understand how they are coupled. How they are coupled indicated with the dot to triangle square. Once they are located, don't see flux at all. Apply only dot sign convention. So that is the note given. To understand the coupling between three coils, first send current from 1, 3, 5 and find flux flow. To find coupling between coil 1, 2 to understand the coupling between three coils, first send current from 1, 3, 5 and find the flux flow direction. Flux flow direction. So once with the help of flux flow direction, then understand the coupling. To find coupling between coil 1, 2 and 3, for example, observe the flux flow direction in the coil 1, 2 and 3, 4 only. Okay. So 1, 2, 3, 4 coupling to understand, observe the flux directions in coil 1, 2 and 3, 4. If they are in same direction, where currents are entering, there you keep the dot. If that flux is opposite, keep the dot in other side. To answer B bit or C bit, use dot rule. Don't use flux rule. Second, to answer B bit or C bit, don't use flux rule. Use only dot rule because dots are already located. So this problem is really tough and I hope you understand this. So we'll stop at this point. Just theory part covered, flux rule, then dot sign convention, then dot rule. These three explained with the help of different examples. Now I stop here, continue next.